Coming here. It's great to see this group is awakening again, thanks to Uri. And I would like to also thank you, Lively, for hosting this event. It's really nice. We have everything. Thank you, guys. And I also would like to thank Uri because he introduced GraphQL, so my talk will make much more sense to you guys. And also, thanks to his beautiful slides, mine will be looking like a cave drawing. My name is Ugur Korfali. I'm working as a front-end engineer at KLM right now. I've been working as a front-end engineer for almost over 11 years. So I'm old enough to remember mootools and prototype. I've worked in many different projects, many different companies as a front-end engineer, also sometimes full-stack engineer. But as I said, for the last 3 years, I'm working as a front-end engineer at KLM. Sorry. So, this is me. I skipped this slide. Okay. I'm working on a product which we call Blue Web right now. What is Blue Web? Currently, you know airfrance.com, klm.com, and those are two different websites. Those are having their own flows. They are using different APIs. They have different designs. Blue Web will converge these two websites into one. So, from the customer perspective, you will enter either KLM or Air France. You will get your own theme, but the whole flow will be the same. Searching for flights, listing the flights, paying for them, viewing your trips, all the flows will be the same. But you will get your own themes. Blue Web product is consisting of many different product teams. And we are calling these UBCs, and I will come to that one, what UBC means. Because in our domain, we have many three-letter abbreviations. Even three-letter abbreviation has its own three-letter abbreviation, TLA. And this Blue Web product is hammered by big traffic, actually. Like, for example, our search component is getting 500,000 unique visitors per day, and our checkout component is having like 720K users per day. So it's really big. And on campaign times, you can double these numbers. Let me just briefly talk about the stack we have. On client side, we are using TypeScript with Angular latest currently. For GraphQL client, we are using Apollo. For CSS, we are using Sass. And all of these are built on Angular CLI. On server, server for frontend, we are again using TypeScript with Node.js. Angular server is our GraphQL server, and we are running all of these on a Docker container with a Kubernetes platform. Okay, now the famous UBC thing. At the start, our architects designed their idea on microservices because it was hype. And they wanted the same thing on front end. And what they imagined, each page, what we are calling UBC, unique business components, as separate deployable products. Like, for example, UBC search is responsible for one goal, which is searching for flights, listing the flights, and at the end, show the summary of what you have chosen for your inbound and outbound flights. This was doable at some point. For GraphQL perspective, it was doable because you can create a GraphQL server and you can scale it by Docker. But in the client side, it was not so much possible because even though you have lazy loaded components, You can build them separately, but at the end, Angular needs to have it as one big application. So yeah, separation was cool because each team can work on their own pace with their own conventions. But what we were losing by this much separating everything. The first one is for the GraphQL part, we were losing the code share because since every GraphQL server were on their own repository, we couldn't share the code. And the second part is considering the front-end part. We couldn't share the data between the screens because since we have separated everything, this front-end was talking to this GraphQL server. So this means this front-end has one client, Apollo client, talking to this one. So for each UBC, for each screen, we have a different Apollo client. In that case, you can share the single store of Apollo client and you can pass the one data you already received in the previous page to the next one. So this was using a powerful tool, but not in a good way. So we wanted to change this. But what we wanted to keep is to be able to work in teams again, because they can build their own context separately, but at the end, what we want to do is merge all these GraphQL, different GraphQL parts into one, so we can benefit one powerful schema from a single server. So at this point, we had two choices because it was like 2 years ago, and the first choice was Apollo schema stitching. This is currently deprecated, by the way. If you search for Apollo schema stitching, you will find some documentation, but you will also notice that it is deprecated because they are currently advertising Apollo Federation. This is like a master schema stitching. It's more complex than schema stitching. It has benefits and also downsides. But back then, it wasn't available. The second one is GraphQL merge schemas. This is more like concatenating your types and resolvers all together and serving as a one GraphQL schema. So this has both pros and cons. And what are those? Schema stitching has the pro that you can keep your GraphQL server separated and you can serve it as a one big schema. But as a downside, you need to write more complex resolvers. You need to work with your fragments in your resolvers, GraphQL fragments. You can search it on Google. I won't go into the details of that one. But it will be more imperative, so everything needs to be imperatively coded. And that's a big downside, I think. And the second thing is this stitching is happening on runtime. So you don't know what you will face with your product when you deploy it there, because it's not built. And if something goes wrong, it will happening on the client. So it was also not a good choice for us. So we went with merge GraphQL schemas. This is just a basic library, which is just, as I said, gluing all your schema types and also resolvers together. And again, this has the same pro with the schema stitching. You can keep your groups separated, your teams separated. They can work on their own. At the end, you are serving one schema. But the con of this one, since everyone is creating their own types, you don't know when you're merging them if they are collide. So you need to prefix or suffix your types. And this needs to be done manually. So this was the downside of the merged GraphQL schemas. And after we moved everything in one repository, we merged every type, every resolvers with the merged GraphQL schemas. We said, okay, what's next? What we can do more? And at that time, Uri introduced GraphQL modules. And even it was not open source when we were using it. This is just one more step more further than gluing your types and resolvers together. It has really good features, which is benefiting you. Again, you can work in teams, and this time it is more encapsulated, and the teams are not touching together. And again, this is also happening on build time. That's another good thing, because before you're putting your schema on live, on production, or any testing environment, you will be sure that it's built correctly. And the third one is it really provides you good reusability tools. So I want to just briefly go over those features. These features are providers, module dependencies, dependency injection, and also resolver composition. So I will just go over these features one by one very briefly. I didn't expect this small screen, so I put some code. I hope all you can see this. Okay, GraphQL providers. This is actually like Angular services. So you have a schema, and this schema has some type and also entry point as a user. And this user needs to get some data from somewhere. And since in our case we are using APIs, this implementation is always the same. If you want to get a user, you go to /user get user endpoint, for example, and it will be always implemented the same way. But each module might need user data. So this logic needs to be reused. You don't, since every team is working on their own way, you don't need to re-implement everything all together. So providers allow you to use an injectable class, so you define it one time. In this case, for example, get user by ID function can get this theoretical data, and it can return it to your resolver. And within your resolver, you have an injector accessible as a third parameter, and from that injector you can just reach your class's function. So every module, in this case, this is a user module, uses the user provider, and for example, reviews module can also go and use user provider to get the user data. So this is really good for reusing your business logic across your modules. The second thing is dependencies between your modules. You can actually, with GraphQL modules, depend one module to another. So in this case, we have my second module. This is created separately, and you have my module, which imports your second module. What is the benefit of this one? On the build time, these are sequentially instantiated. So before instantiating your my module, it first goes and instantiates your imported dependency module, and then reinstantiates your own desired module. So this is really good to create a relation between your modules. The third one, dependency injection. This is again like Angular uses. You can inject some services with different configuration in your module with injection tokens. So when you're writing unit tests, you can easily mock these, because they are just basically injected within your model with some injection tokens. And you can either inject a class or a string constant value or a factory function. And last but not least, sometimes when you're writing resolvers, of course you will have your business logic, but next to your business logic, sometimes you have some helper functions to prevent that resolver getting accessed by unpermissioned people. So let's have a look at this example. We have a business logic here, but before that business logic, we want to show if the user is authenticated, and also the authenticated user has the right rights to access this business logic. And yeah, this makes your resolver a little bit more complicated than it should be. So with resolver composition, you can just extract that extra logic, and you can create your own functions with the same signature as your resolvers. So it has the same input signature, and you can create reusable functions. And in your module, you can say, okay, whenever I query my query, the naming is weird, but whenever I query this query, then you need to run these two functions to be able to execute the inner logic of that query. So this is also, again, really reusable. And since it's composable, you can share this logic across your modules again. And yeah, this was our base structure of GraphQL. So we had our different schemas all together in one schema, and we can build them. So we don't need to get runtime errors on our schema calls. And on top of it, we have these great tools. One of them is code generator, GraphQL code generator, which we already mentioned it. I will just want to show you three of its plugins, which are TypeScript types, introspection, and fragment matcher. So, sorry, I need to get out of here. Where's my mouse? It is so small. Yes, let me just make it bigger for you. Is it readable a little bit? Perfect. Just a bit. One more. Yes. Okay. Since we are using Angular, we are using it with TypeScript. So when you are writing your queries and resolvers, both in front end and back end, you want them to be typed. So GraphQL is already out of the box providing you typed schemas. So you want to benefit these types also in your code. So here we have an example schema. For example, let me see if there are. Yeah, this is harder than I expected. For example, this field is not required, and the ones with the exclamation mark are required. And here, the generated types, for example, as I said, this is not required. That's why it is typed with question mark. So this is automatically done for you. So you can import this one in your code, and you have the benefits of the autocomplete. The other one, wow, this is hard. GraphQL operations. This is also using your queries. So you can even have, oh man. You can even have types for your query arguments even. Everything will be typed end to end from backend to client. So this is really powerful. And the last one is fragment matcher. This is also really cool because sometimes you want to use interface types and also union types, because sometimes your types can be consisting of two other types. You can merge them and create another type from those separate types. But in Apollo client, they're using a heuristic guess for your query types. So if you are creating your type out of two types, it cannot guess which result you will get. in that case, you need to provide your Apollo client with some possible types for some specific type. For example, this node type can return a user or a chat or chat message. So you need to tell your client that it needs expect to get these 3 types out of this one. So if we go back to the slides, if I can get my cursor back, yes. So yeah, GraphQL code generator really helped us to create our types without any effort. So we know everything we created on GraphQL, it will be typed on our resolvers and also in front end. And again, as Uri mentioned, there's really powerful tool that we call GraphQL Inspector, because now you have a single schema which is really powerfully typed, but you want to maintain this one. So whenever you change something, you want to be sure you're not breaking your schema or you are creating extra types. So GraphQL Inspector will help you with that. It has some features like compare, validate, coverage of your schema, and also finding out the similar types. Briefly, the compare can, as it states, compare 2 schemas to each other. We usually compare our PR schemas, like the end result of our future development, with the schema which we have on master. So if you have breaking changes, it will let you know that if you remove this type from your schema, you will break your front end. So this is really important for us to know before we deploy something on production. Validating your schema is helpful because sometimes you do, even though you use autocomplete, you can do some typos, and it will warn you that you are trying to reach a field which is not existing on your schema. So it will give you an error, and also it warns you if you are trying to reach a deprecated field. And this warning is really beneficial because of this. If you are deprecating a field on your schema, so you're letting your developers to know that they shouldn't use that field anymore. So coverage goes over your queries and it runs your queries according to your schema, on top of your schema. And it gives you a report that, for example, created that and modified that are not even touched when you run your queries. So you know that these fields are safe to remove from your schema, so you won't confuse any more colleagues anymore. And the last functionality is similar types. This is again really important because when you're working with teams, most of the time you cannot check all the PRs and some types are recreated. So they are getting duplicated. And this shows you the similar types. For example, this blog post type is really similar to mail post, post or email post. So you can maybe choose one as a base type and extend the others to this one. So you can, again, share some types. Of course, after implementing everything and coming this far, we are still not at the end. There are lots of things we need to do. And one of them is increasing the reusability. Since we came from different servers and we merged them together, some of the business logic are still repeating itself in our code base. So we can just use providers more efficiently and reuse those business logic between our individual schemas. And also consolidating the schema. This goes well hand to hand with coverage, and not coverage, finding the similar types of the GraphQL inspector, we need to find out the types that we are using over and over again, and we can create a single type out of them so we can share across the whole schema. And if we can manage to do this, this will make our pages, UBCs, work together really well. And that's all I can tell you about our story at KLM. And if you have questions, I can answer them, or we can wait for the Q&A panel. So thank you very much for listening.